Cross-site scripting, or XSS, is one of the most common vulnerabilities of web applications. It's caused by improper input and output validation. So generally it happens by including malicious client-side scripts into web pages. And when a victim visits the page or clicks a code-injected link, then the malicious script code is executed. And at this point, the victim's browser has no way to determine whether the script is trusted or not. So it'll just execute the script. And by the execution of the script, it can access cookies or other sensitive information retained by the browser. Such a script can even rewrite the entire content of the HTML document. Although XSS attacks are possible in VBScript, ActiveX, Flash, and even CSS, the most used language, of course, is JavaScript. So executing untrusted JavaScript code in browsers can have devastating consequences. Anyway, we can divide XSS attacks into 3 types: reflected, stored, and DOM-based XSS. So in the next few lessons, we're going to cover XSS flaws in detail. So this type of XSS vulnerabilities occur when the malicious input in an HTTP request is immediately returned to the victim's browser in an HTTP response. So the malicious input data is not stored on the backend. So that's why we call it reflected. What the attacker enters is reflected to the victim quickly. Now, it's also known as non-persistent or first order or type 1 XSS. Reflected XSS vulnerabilities require the malicious script to be embedded into a URL. So, as a pen tester, we should try to find a way to entice the victim user to click the link containing the malicious script. Now, in order to be successful, the user needs to click on the infected link. But before that, we need to use whatever social engineering technique we need to deliver the infected link to the potential victims. So open Kali and log into BWAP, just like we always do. Now, as you can see, there are many examples of XSS vulnerabilities in BWAP, and I'm going to exploit some of them, not all. So let's first choose the XSS reflected get. And it's nothing but this sample page. But what you type in the fields will be reflected to the page. And then the values will transmit over the URL. And view the page source. And here are the values I typed. So this is a suspicious form. Okay, so now let's have a look at the code. Now, here at the beginning, there is a function named XSS, and it calls XSS check3 and check4 functions according to the security level. So scroll down a little bit, and it grabs the values in the form, then it uses them in the XSS function. All right, so if the level is low, the values will be printed to the screen directly. If not, XSS check3 and check4 functions will be executed for medium and high level. And this function is in this file. We'll scroll down, and here are the functions. So check4 uses add slashes function to prevent these characters. And check3 uses HTML special chars function with encoding. So go back to Firefox, and I'm going to paste HTML1H1 tag in here, and it's executed. So view the source, and here's the problem. So the input is not sanitized at the back end and added the source of the page. So let's look to see, and there's no difference between this tag and any other HTML tag on the page. No encoding or anything else. and this tag is reflected with the page to us again. So now I'm going to paste another HTML tag. And it's here in the source. Okay, so this time I'm going to add this tiny JavaScript code, and it's also executed. So view the source, and here are the script tags that we sent. And now I'm going to change this JavaScript code a little bit. Then fill in the form and go. And in the message box, we see the cookies and the session ID as well. So how do we benefit by executing JavaScript in the browser? So JavaScript provides us the power to do many things browser side, but we do have to use the browser. So in order to hack, we need to execute JavaScript in someone else's browser. So copy that URL and open another tab and paste it and go. So you can see JavaScript payload in the URL is executed as soon as I open the page. Or, in our scenario, clicking a link. So we need to deceive the user to click a link, right? But alerting the session ID is not a good way. So you can use this code. It will send base64 encoded user's cookie to my application. You can download and host it on your Kali or your host if you like. It's a simple Bootstrap 4 app. So paste this payload in here. Open the Web Developer tool, then go. And what do you see? The code is sent to the server, and nothing happens at the back end. But then the JavaScript code is reflected to the page, and then this JavaScript code executes and sends the encoded cookie value to my grab page. So view source. And our payload is perfectly displayed here. So now go to the Cookie Stealer app, refresh the page, and we have an incoming session. So click to log in. Username is awapt and password is 12345. And the cookie with the session ID is here. Now from the More button, you can view details about incoming requests. You can check to see if the session is live or not. Return to sessions. Also, you can view the main page on BWAP. And as you can see, here's our current user. Okay, then go back to Kali again. And I validated the XSS vulnerability. So now copy this URL, then log out. Open BWAP with just as another user. So I'll log into it as BWAP user 1. And let's say somehow I've sent the link to this user and the user clicks on it. So that means I'm just going to paste it here and hit enter. View source. The value in the URL is lying in the source. Then go to Cookie Stealer app, refresh the page, and here is a new user's cookie. Now go to session, and it is BWAP user 1 session. So we stole the session ID value of the user and we'll use it to authenticate ourselves. Good. So let's have a look at some other examples. So BWAP handles different aspects of XSS very well. And the next example is one of them. So after logging into BWAP, choose Reflected JSON from the menu. And there's a search box on the page. So let's examine the page a little bit. So I'm going to type THOR into the box. And yeah, we have that movie. It's a positive result. Now, what I type is also in the URL. The title parameter holds this value. Okay, so now let's view the source. And here's the result. The page sends JSON data. Then this data is parsed and printed to the page. All right, you ready for another? Enter IRONMAN without spaces. And a negative result comes back. But also the data is reflected. And the value is still in the URL. So view the page source again. Now, this is my input, and it is reflected to the page. So like I did in the previous lesson, paste the HTML H1 tag. Okay, it works. And paste the NBA link. Okay, so something went wrong here. Let's view the source. The link is here. Okay, I think I found it. Did you? So the single quotes cause the problem with JSON data. So if I add backslashes before the quotes, it will work. So this problem is solved. Now, before we go any further, I do want to show you the code. So open terminal and just have a look with me. Now here, if the level is low, the title parameter is used as is. If it's not low, it is checked with a function. Then the output is generated, and scroll down. So now here is the script, and the output is added into the script. And then as you see, if the result is negative, the search term is sent back to the browser. So go back to Firefox, and we can run HTML tags entered into this field. So let's paste this tiny script. Okay, no, it doesn't work. So now to figure out what's happening, let's view the source. Because my input breaks the original script, right? Now this part is between script tags. So it can't be executed if there's, anything meaningful. And the rest is not between script tags. So the browser uses the remaining part as text. So it displays text in the page. So now type Iron Man to clear here and view the source. Now we can create our payload, which doesn't break the original script. So I'm going to just write it here, and step by step I will create the payload. So first let's close these double quotes around our input. Then using this curly bracket, and then this bracket, and then this single quote around the JSON data. Then a semicolon to end this line. And close the opening script tag. So now we can start our payload. First alert the cookie as always, and then add an opening script tag. And that's it. So let's copy this payload and paste it in the search box. And yeah, the JavaScript code executes. Now let's view the source to figure it out better. And this is the first part, so it doesn't have any meaning to the page. And then this is our actual payload. And then this part is the remaining code. It also doesn't really have any meaning to the page. Okay, so let's go back to the page. Now we can send the session value to our cookie stealer app, and we have the payload. So I'm going to copy it and add it here instead of the alert code. And then copy this line. Open the Web Developer tool. Paste the code into the search box and go. The requests sent from this page are below. And base64 cookie value is sent to our Stealer application. So view the source. So our good payload is lying in the source. So open the Stealer app, refresh the page, and the cookie values come up. So now let's go to our session. This is our user, and we are able to send the user session. Okay, so go back to Kali. Now we can use this URL to get any user session. So we can deceive a user to click on a link comprised of this URL. Then get the session. And we've already done that in a previous lesson. So I'm going to leave that for you to do. All right? SQL Injection. So the SQL Injection is the most famous and perhaps the oldest web application attack. It is an absolute nightmare for data-driven applications. So let me talk to you a little bit about it. Thanks to Web 2.0, users can interact with applications in different ways, right? And applications can use user-supplied data to perform any task on the back end, such as selecting, deleting, updating, and so on and so forth. So if users provide valid and secure data, right, there's no problem. But what if users try to inject codes instead of data? So actually, this is a huge problem for web applications because they can confuse a lot of actual valid data and code. So that's why they need to differentiate between valid and invalid data. So SQL injection arises when the user or pen tester injects SQL statements into data that's sent to the server. And then if there's no sanitation, escaping, or any other security solution, the injected data can run on a database server. So the result of this execution will be sent back. And then lastly, the web server processes the query result, prepares the response, and sends it back to the user. Okay, so that's how a basic SQL injection works. But by performing this task, one can easily read and manipulate sensitive information that's stored in the database. So here we're not just talking about the data being like on fire, but it's like the whole system is in danger because database servers are allowed to use and issue operating system commands. And if they're not configured properly, the pen tester or the attacker can even gain access to the entire system. So anyway, we can divide SQL injections into 3 classes based on the extraction of data. Inband. So this is the most straightforward injection attack in which retrieved data is presented directly in a web page. Inferential or blind. So in this type, there's no actual data transfer, but the tester is able to reconstruct the information by sending particular requests and then observing the resulting behavior of the database server. Out of band is data that's retrieved using a different channel, such as an email with the result of the injected code. So now we also have 5 techniques to exploit SQL injections. The union operator can be used when the SQL injection flaw happens in a select statement, and it makes it possible to combine 2 or more queries into a single result set. The Boolean technique, so we can use Boolean conditions to verify whether certain conditions are true or false. The error-based technique forces the database to generate an error, giving the attacker or tester information upon which to refine their injection. The out-of-band technique is used to retrieve data using a different channel. and time delay techniques. Time delay techniques use database commands to delay answers in conditional queries. So it's very useful when an attacker doesn't have some kind of result immediately from the application. Okay, so now let's examine some of them. So open up Kali and go to BWAP. Open up the drop-down menu, and there are several types and aspects for SQL injection in BWAP. Choose SQL Injection, Post Search. Okay, so there's a simple search box here. So let's write in Marvel movies and search, and it will bring the result into a table. Okay, so now enable Foxy Proxy, and then type something in search. Go to Burp, and here's the request. It sends data over post, and the post parameters are here. Okay, forward. And here comes the response. The returned data is in a table. So we're going to play with the request later. So for now, open terminal and view the page, SQLi6.php. Now, according to the levels, there are security checks. So we're going to view each of these functions after this file. So we'll scroll down. Now, this is the SQL sentence to perform search operations on the database table. And below is the code that helps to display the data. So exit, and for the functions file, the check1 function adds slashes to the data provided by the user. And of course, we also have seen that function before. And the check2 function uses a built-in function to escape SQL-related reserved characters, such as the double quote. Okay, so go back and open up Chrome. And I'm going to open PHP MyAdmin, choose Movies table, and open the SQL tab. And I'm going to paste the SQL sentence used in the page here. So this is PHP syntax. I'm just going to clear it. And this is the pure SQL sentence to perform the search. And SQL injection happens by injecting this sentence. So let's type something here. And here's the result, one line of data. So what happens if you add a single quote? Okay, so you'll get an error because single quotes are special characters to SQL. And the first two of them are paired, but the last one is not. And it confuses MySQL. So now what happens if you add a hash symbol here? Hash or pound, whatever. It'll execute, no errors, because the hash character is also reserved for MySQL. The hash is used to comment the text in a line, as you can see here. So I think that gives you a pretty good example of how SQL injection works. So now you can do the same thing on the BWAP page. Put in a single quote. You get an error. Put in a hash. And no errors. So that also means that you can execute SQL. So now let's write some smart queries to get data from MySQL. Add order by 10. And by the way, order by 10 will order the result by the 10th column. And if there is no 10th column, then you'll get an error, as you can see here. So that way you can discover the column numbers in a result set. Okay, so it's not 8 also. But it's 7. So 7 columns are in the result, but only 5 of them are shown on the page. So now we can use the union operator to merge our own select query. So I'll write this in to see what columns are displayed on the page. And here's the result. Second, third, fourth, and fifth columns. So now instead of these numbers, we can use SQL statements and functions to pull data from the database server. And now I'm going to paste this payload to find these values. And the version of the database, the current user of the database, and the current database. In an SQL injection process, you extract data step by step. So first you get the version of the database, then the name of the user, and then your current database. Then you can pull data through databases, tables, and columns. So that's the way we're going to do it. Okay, now with this payload, discover the database names on this server. And here are the databases and their properties. So the target database is BWAP. And paste this payload to see the tables of BWAP. And here it has 5 tables. So here now you can see the row numbers of the tables. And this is where you get to choose a table to target. So I'm going to get the columns of the movies table. So here are the column names. All right, so now we can pull data from this table, write this payload, and we'll put data in the first column. All right, so now, in this scenario, there's no crucial, any important information, right, in this table. But just think of it as being able to execute SQL statements. So then you can get, well, almost everything from the database if the current connection user has rights. So in this example, we can do all of that. For instance, we could get MySQL users and their hashes with this payload. And you can always crack hashes later. Now remember earlier I was saying database systems generally have the capacity to execute operating system level commands. So that means that you could possibly, if you were so inclined, run such a task. Okay, so I'll say that, for instance, you can view files on the system, right? So the magic file can be loaded onto this page with this payload. Now, I think you'll remember the content of the password file. You can also upload files to the server, actually to the database server. But you do have to bear in mind that your connected user should also have the rights and permissions in order to be able to write data to a directory on the server. So I'm going to upload a sample shell to the BWAP directory, but I can't. So I need to find a particular folder to see if it exists. And let's see if I can find the documents folder. So paste the payload and search. And yes, we upload the shell. Actually, it's not a regular upload. We just wrote some data to a file on the server, that's all. And I write a simple PHP shell like we used before. And now let's see if we can run some commands. Go to the documents folder from the URL and call shell.php and add cmd as a parameter with a Linux command. And here is the result. Now, of course, you can change the commands. Who am I? Which NC? I want a different shell, a netcat shell. All right, so now I'm going to listen on terminal, nc-nlvp4443. Okay. Now I'm going to paste this one-line netcat reverse shell and hit enter. All right, so you see the response doesn't show up. So I think it works. And, yep, it works. bbox connects to the port on Kali. And you can run Linux commands now and run this Python code to get a bash-style shell. Okay, so we got a full shell from a simple SQL injection. So the rest is up to you and your imagination. And now we're going to look at some different examples. Now, if you remember in the previous lesson, we exploited a SQL injection vulnerability in a search box. And the search function basically compares the user's input into a database by using a like statement, right? So then we created SQL queries that can work well with the like statement. So now we're going to do almost the same thing, but this time with something different. Let me show you. So go to BWAP, choose SQL Injection, Post Select. So on this page, you select a movie, and the information about movies will show in the table below. And to see the HTTP request, enable the Foxy proxy and select a movie. And it is a post request. And the movie ID is sent to the server. All right, so nothing else needs to be in the request. Just send the request to the repeater tool and forward it. And look at that. See, the information about the movie is in the table here. Then forward and intercept off. Now, before we go any further, let's have a look at the code. So function is here to call security checks according to security levels. Okay, we already displayed the functions. So scroll down to see the SQL query, and here's a query. So it has two parts. Now the second part is where the user input comes in. So it takes an exact numeric value and then selects everything about this record. So we need to write appropriate queries to work with this query. And then the remaining code will display the output. But now, here's a problem. Only the first record can be displayed. So when pulling data, we need to be concerned with this, okay? Only the first record can be displayed. Remember that. Okay, so go back, open repeater, check the main request again, and it shows the data. So put a single quote, and look, we have a syntax error. So then put another single quote, and there's the same syntax error. Another one. Syntax error again. All right, so I'm going to add a different payload. And this time it works. So I think this movie must be the first record. So now I'll discover the column numbers, order by 1. The movie name is changed. That also proves the vulnerability. 3 columns. No. 5 columns. No. 7. No. 9 columns. No, but we do get an error. 8 columns. No, and an error again. So the number of this columns in the select statement is 7. Now, of course, I already know it, but let's have a look at the way that we detected it. So I followed it this way. Okay, so now write this to discover which columns are displayed. So except 1, all are displayed. SQL injection is identified. So we should pull actual data and metadata about the server. So first, let's pull version, user, and current database. We are the root user and use the BWAP database. and the version is 5.0.96. And we can also look up vulnerabilities for this version, but it's not in what we're doing right now. And by the way, you can always change this number to null. It'll also work. Okay, so get the database names. And this query only gets the first record. So we need to change it. So if you add a limit clause like that, you can pull all the database names in turn. And this will get the information schema. So next one is BWAP. Then 2, then 3. You can also try this one. All right, so now we have all the database names. So then we can get the table names. And it will display only the first one as well. And we can use the limit clause just like that to specify all the tables. Or this payload to group them. All tables are in one row now. So to get the tables of the BWAP database, use this. 5 table names are here. And then we need column names. And this restriction looks familiar, just the first record. So adding the limit clause, we can pull the columns. Yeah, but it's not very efficient, is it? Especially when you manually exploit the application. So use this to get the columns of the movies table. This one's better. So now we know the information about the database and tables, so we can pull the actual data. And this payload can work, but we need to get over our one-line problem. How are we going to do that? Well, the limit clause can help us again. But I know this way is kind of boring and slow, but let's just stop for a second, and it's not an exercise anymore. Let's think of it as a very important table, so it's worth the step-by-step approach. Of course, you can also write a crazy query like this. All right, so anyway, all data is grouped into one line. And due to being able to read and write files from and to the system, I think you can go ahead and run this payload. And then this payload will send the result to a file. And don't worry about the warning. It works. And with this new payload, you can view that file. Okay, so now it's time to increase our level to medium. So I'm going to just change this here to 1. But this time, the query below won't work. So the problem here is single quotes. The application sanitizes the input. So that means we need to get rid of them. But instead of just writing strings in single quotes, I'm going to use the char function with ASCII values. So let's see how that works. Just like that. And the columns, they are all here. And the magic file? And you know this. So good. And the rest is here for you to discover. So until now, we have exploited some SQL injection vulnerabilities. But the main SQL queries are all built with select statements. So we add our payloads after a select statement. Now this time we're going to, maybe just do something different. And we're going to perform an SQL injection over insert statements. So let's go to BWAP and open SQL Injection's stored blog. You may remember this page. It has, well, almost the same view as stored XSS, but the backend code is completely different. So it's kind of like a commenting page. So here you can enter something and it will be displayed below. Okay, So open the terminal, type vim sqli_7.php, and the security check is performed based on whatever the security levels are checked. Scroll down below, and in this line, the user's input is checked. Then the insert statement comes, and it uses the user input and the session username to insert to blog tables. And below there is a select statement to display the entries in that table. And it selects all the records to display. So first it shows the owner of the entry, then it shows the entry itself, and the rest is not very important. So go to BWAP. Well, no, actually go to Chrome. So if you're not already, just log in to PHPMyAdmin. Open an SQL window. So I'm going to paste the PHP code here and clear it. All right, so this is pure SQL query. And our input data will come into between these first single quotes. Okay, and when you put in a single quote, as we did previously, see how it won't cause an error? It will insert the single quote into the table. But if you add this payload, it will just execute the query. Then insert A and B into the movies table, and the remaining part will be executed as comment. Okay, so copy that payload if you want. And go to Firefox, paste it in here and add entry. So you see, there's no problem. So the last line proves the insert process. Okay, then paste this one. This shows the sub-select queries also causing no problems. And now we can enumerate the database itself. So now write this payload. And here are the values of the version, the database, and the user. Now the payload we provide selects the data from the database, and then the original query inserts that data into the movies table. The second original select statement brings the records into the movies table. So, okay, let's go with databases on the server. So as you see, we can only view one database, the information of this one database. So the problem is in the insert statement. So because we use sub-select statement in insert, so the insert statement can only insert one line. So that's why we cannot see all the data together. And we can use a limit clause, and this is information for BWAP. But you can do this for the other ones in this way as well. However, if you group the names, there's no problem. So you see all the names are here? Now write this payload to get the table names. Yeah, we get an error. And it is indeed a syntax error. Okay, so now it's done. So with this payload, we can one by one read each table. But I have nothing to do with the system tables now. So I need BWAP's tables. And here they are. So now we can get the column names with this payload. And we need to go one by one. And once again, I only need my target table. So I'll paste this one. And then these are the columns of the users table. And now we can pull the actual data. Okay, so you can use this payload to bring the information from the users table. But you do need to go one by one again here. And now, of course, I don't want to finish this lesson without my magic file. So use this payload to load the password file. And yeah, I'm sorry, we cannot view all of the content at this time because here's yet another restriction. So normally we inject into every parameter, but the result of the sub-select statement is inserted in the owner column. And then the size of this column is about 100 characters. So that means that we're only able to read this much data. But you get my meaning. So now we're going to do the last Inband SQL injection. The first two are based on the union clause, but they have different aspects. And this one also has, yet a new aspect. So in this example, we're going to bypass a login form. All right, so open SQL Injection login form hero. And as always, we'll need to understand how this form works. So I want you to enter something into the login, invalid credentials, and fill both invalid credentials, and put a single quote. Okay, so we break the SQL query used by the application. So now we need to fix this query and pull some data. But isn't it better to see the code before? So let's view the code file then. Regular security check functions are here. So scroll down a little. And here is the SQL query used. So it uses both values in the query. The query executes. And if there's no error, it fetches the rows. And if the login column in the row is set, then it displays the data. And if it's not set, invalid credentials is the error that gets displayed. Okay? So go back to Firefox now. Go to Chrome. Open PHP MyAdmin and log in. Now choose the BWAP database. Now you don't have to do this, but I just want to show a clear picture for you. So this is the PHP code to log in. Okay, now I'm going to clear it. So now it is pure SQL. And if I add a single quote here, this error will arise. So I've added a hash also, and no error this time, because the hash makes the rest as comments, you see? So now I can write my statements here like that. So you see, it's simple but perfect query. Okay, so now go back to Firefox, and I'll give this input. And you see there is no error. Therefore, the login column is set. So the application also authenticates us, or we're logged in. So now give the same input again, but change 1 to 2. There's no syntax error, but invalid credentials. Okay, so now we can enumerate users. And don't forget, here we will have that first line only problem as well. So let's just add the limit clause. Limit from 1, limit from 2, limit from 3, limit from 4, from 5, and limit from 6. You get the error. Okay, so there are 6 superhero users in the table. Now to go further, we will need the number of columns in the query. So order by 3. That works. Order by 5. it doesn't work. Order by 4. And yeah, so there are 4 columns in the select statement. So now let's see which columns are displayed on the page. Yeah, so it's the second and fourth columns. Next is the current database name and user information. So we can use the BWAP database over root user. We can add version and group them with this payload. We already know, but it is always good to validate. And then we can discover all the database names, but step by step. So use the limit clause. Next one is BWAP. Now, sometimes you may need a database language and collation settings to perform some of the payloads. So you can always pull this information, as we have done in previous lessons, and group databases like that, and use the limit. Now pull table names. All right, so this payload will do it, but you need to use the limit clause, and it can take some time. Also, this payload can be used. So any way you do it now, you can mix it up how you want it. I think you get the idea, right? So list BWAP's table like that. Then list the columns in the heroes table. And then pull the actual data from the heroes table. And use a limit clause. Limit from 1. And if this way is too boring and tiring for you, you can also use the load into file statement. So the result will be saved to a file called result.txt. And then with this payload, you can view the result.txt. And perhaps that's much better and quicker for you. Okay, so we're done with that example. And it was indeed the last Inband SQL injection. But actually, now that I think about it, there is one error-based SQL injection. And you will drive queries based on the errors. Okay? And then, of course, the rest will be up for you to discover. While testing, it is very important to look at all input fields. And when you find an input field, you will try your payloads. But you probably won't get SQL errors. Then you might think, well, then that means there's no SQL injection here. So actually, yeah, it's possible, because web applications can send generic errors, right? So you may get confused to see whether your payload executes or not. Let me show you something. So now go to Kali and log into BWAP. Now we're going to look at another SQL injection type. So from the menu, choose SQL Injection Blind Boolean based. And it's a simple search box. Now, if you look for a movie in a database, you will get a positive result. But if the movie's not in the database, then you'll get this negative message. And if you try something to break the SQL syntax or to cause an injection, okay, then you'll get this generic error. So at this point, what do? We've got nothing left, right? Okay, I mean, I turn to you. No, I'm just kidding. But in the real world, for instance, you will get a 404 page in this situation. But you and me now, we're not going to give up, are we? So what do? Well, let's go and open Terminal and let's have a look at the code. Now, we always see these checks, so scroll down. And so here's the part that I want to show you. Here is the SQL query. So see how it uses the title parameter, coming from the user. Then the query executes. And if there is an execution error, it will print incorrect syntax error. But then if there is no error, it looks to the record set to see whether it's empty or not. So if it's not empty, this means that the movie exists. If it is empty, the movie doesn't exist in the database. Okay? So let's go back to Firefox. Now we're going to blindly try our payloads to verify if there is an SQL injection. Now I said blindly, but logically, write this one to test. And it breaks the syntax, but we don't know how. So now try this one. Now, I think it should work, but we do get a negative result. So now try this one. And once again, I think it works, and we get a positive message. So now change 1 to 2 and try. It works, but the negative result appears. Okay, so we can understand if our payload executes or not. And also we can pull data by checking the execution result, whether it's positive or negative. So now I'm going to add something here. The first part of the payload before and is always true, right? And MySQL will check if the second part after and is true or not. And then that way we can learn the length of the current database name. Negative, the length is not 1. So change 1 to 5. Positive, the length is 5. So now use this. And it will check the first character of the current database name. It is not A. It is B. Is the second character W? Yes. Is the third character A? Yes. Is the fourth character P? Yes. And is the fifth character P? Yes. So, the database name is BWAP. I think you get the point. So we use Boolean operators as well as some other functions to compare. Now, of course, there are multiple ways of comparing. This is just one of them. But it checks if the ASCII value of the first character of the database name is greater than 64. Positive result. So the first character can be either lowercase or uppercase letter. So I use this one. So now we get the first character is a lowercase letter, and we can make a Boolean search to find the first character. So is ASCII value greater than 109? No. Is ASCII value greater than 102? No. And is ASCII value greater than 99? No. And is ASCII value greater than 97? Yes. Okay. Is ASCII value 97? Yes. So finally we get the ASCII value of the first character. Now you can perform almost the same payloads to get other data from that database. But of course you might be tired and bored, because this is really long, right? It takes a long time, but you're seeing how it works. But think about the nature of the information, the quality of the information that you can get from a real-world database. You need to be proud of yourself. But me, I'm going to stop here. But you can go ahead and try some of the other payloads and figure out what else you can do. All right? Cool. So now in a normal scenario, when you get an SQL error, then you can shape an SQL injection attack. And when you don't get an error, you can try Boolean techniques. But there are other times that sometimes even this doesn't work. So in this lesson, we're going to examine another SQL injection. Okay? Open SQL injection, blind, time-based. So as in the previous lesson, you will see a simple search field. So let's try something to search. And maybe a single quote could leak something. Nothing. So it seems that we always display the same page, same response, yeah? And we have nothing to determine whether our searches or payloads reach the database and execute. Okay, folks, open your terminals before going any further. Vim SQLi _15.php. So on line 26, error reporting is turned off. That explains why we don't get the errors. And regular security checks, here they come. So this part is important to us here. The SQL query is just like this. It's not any different to the previous query that we see in Boolean-based SQL injection. Then this query executes. And if there's no error and the result set is not empty, then it does something. Actually, it sends an email to the user's address. So scroll down a little bit. Now, this is the search box. There is no PHP code that can affect the page here. So go back. Okay, I forgot to try Boolean values. So type or 1 equals 1. Nothing happens. Add a hash character. No, nothing? All right, change 1 to 2 and try. Nothing happens. Yeah, and I'm the one who's supposed to know what he's doing, right? Now, what I'm showing you here is you can tell that comparing with Boolean operators doesn't necessarily work all the time. So that means that we need to use time-based SQL payloads, which is what I guess I began telling you. But I want you to see when you need to use them, right? So now let's have a look at this payload. Now focus on the AND statement. So if the whole query is legitimate, the left side of the AND will execute very quickly, and the right side of the AND will sleep for 2 seconds and then execute. So we're going to observe the page for the response. If the page loads approximately after 2 seconds, then it means we get an SQL injection. So click Search and look at the left lower corner. Browser's waiting for the page. Now, I forgot to count for 2 seconds, but you can see it works. And then you can shape the payload to pull data. But I'm going to show you some other types of payloads as well. So let's have a look at this one. Oh, no, wait. You can also use this, the benchmark function. So there are several payloads with benchmarks. And now we can perform the version detection. So use this payload. And if the first character of the version is 5, it will sleep for 2 seconds. Yes, so it waits. So you can get all one by one. And then write this payload to get the first character of the current database. The page will load after 2 seconds if it's B. And yes, it is B. Okay, so try this one to get the length of the current database. Oh, no, wait. Then change it here to 5 and search. And yes, it has 5 characters. So to learn the length, you can also use the like operator with placeholders. So let's add one more placeholder. Yeah, it works. Okay, so I think I think you get the point now, yeah? Now, I, of course, have several other payloads, but they do pretty much the same things. So I'm going to share all that with you in a separate file, and I'm going to stop at this point, and you can try some of the other payloads on your own. Go for broke, see what you can do. All right, so we detected and exploited different types of SQL injection in the previous lessons, and we performed manual detection and exploitation. It really is important to get the idea behind an SQL injection. And I think we've, covered it enough. So now I would like to introduce you to a wonderful tool. In the next 3 videos, we're going to cover the SQLmap. But first, I want to start with some basic options. So I'm going to use this SQL injection page, and you can open it from the menu. It's a simple search over the HTTP GET method. You can type in something to search, and the typed input is in the URL, as you can see. Okay, so copy this URL. Then open your terminal. Now, SQLmap is a built-in and free open source tool in Kali. And I think it's going to solve many problems while you go along SQL injecting. So with 1H, you can see basic options, and we're going to cover most of them, but the usage is quite simple. I think the developers did a very good job here. So it simplifies the detection as well as the exploitation. But wait, there's more. With H, you can view even more options and more advanced scenarios. You can use them here. So let's just stop right here and run it. So type in SQLmap U and paste the URL here between the double quotes. So this is the target URL. Then ptitle to specify the target parameter to test. And type --cookie to add cookies. Now you may need a session value or something in a cookie, so you can provide it with this parameter. So go to Firefox now and open Developer Tools and go to the Network tab, refresh page, and click on a request. And copy the value of the cookie header. Paste it here. Then you can randomize the user agent with random agent. And the H parameter will add a special HTTP header to the requests sent by SQLmap. So I don't know if you can see it, but this is handy because you may want to follow SQLmap requests in a log file or any security device. So I'm going to add this header, and with a DBMS parameter, you can point directly to the database management system of the backend. And also you can specify the operating system with the OS parameter as well. Then F for fingerprinting the database, B for banner information of DBMS, and then add current user and current database. Then check to see if the current user is a database administrator. Okay, so now we've completed the SQLmap query. So I know it looks like a long one, but it's very clear. Okay, hit enter. So it detects an injection, and now if you accept, it will try another type of SQL injection payload. So look, it finds several others. The title parameter is vulnerable. And if you want other parameters to test, you can always press Y. But choose no. We don't need the others now. And then let's see how it finalizes the execution. And now you can see the results here on the screen. And there happens to be a copy in this file. So let me show you. It's under root directory in a hidden folder. So we'll open the log file, and here is a complete information about our finding. See the payloads and the discovered information. Okay, so go back to the terminal. Now I'm going to run this one. Users is my parameter for getting database users, and the password parameter for passwords of the database users. You can also get their privileges and roles also. So I think the parameters are clear. It gathers users, then passwords, and then it can even crack the hashes for you. So accept it by hitting enter, choose one, and no. Then it will try to crack the hashes with its own dictionary file. Okay, the execution is finalized. So go ahead and open the log file. And here's the output of the second query. The payloads and the users are here, the passwords and the hashes are here. Then the privileges show up. Scrolling down, and here are the database users' roles. Okay, so go back to terminal. And now let's use this query. It will get all the databases with DBS and enumerate all the information about them with a schema. It will bring in everything about the databases, and of course the output is very long. And you can analyze it later, but this time just delete the schema parameter. That's the one that causes a long input. So here are the database names in the server. So now we can choose one of them with the D parameter. And it lists the tables in it. Okay, so now we can choose a table with the T parameter and see the columns. And these are the columns of the users table. Great. So now we have the information about the database, the table, and the columns. So we can pull the actual data. So just use the C parameter and type the name of the columns. Then simply dump. And it runs quickly. So here's the result. And we can delete here. You can dump the whole table also. It'll detect the hashes again. So choose one and crack them. And thankfully, it cracked the hashes. And yeah, so here is the result. Perfectamundo. Okay, now use this query. The SQL shell parameter will open an SQL shell for you to run SQL statements. So this is very cool. You can run a SQL query here. Select ID login from bwap.users. Oh, something's wrong here. That's it there. I got to add a comma. So it's a really cool feature. Okay, so go back. Now use this query. An SQLmap provides reading and writing files if possible. So you can read the magic file just like that. And now you can accept this to let SQLmap confirm the download, and the file is in this folder. Go ahead and check. Okay, so now we can upload a file, but not an oh-so-innocent file. So I prepared a simple shell, and with the help of these two parameters, I can upload to a destination on the server. And again, it wants to confirm. The file is not uploaded. You know, I think we don't have the right permission to do that to the directory. So let's just change it to this one. We can confirm again. And I think that uploads the file. So we'll add the command parameter like that. Okay, so now we have a web shell, and we can run Linux commands. So go to terminal. Now, instead of using the web shell, you can use this query. It will do almost the same thing that we did. It will upload a shell file to the server. Okay, choose for and a writable directory. Type no. Choose to provide the writable folder, and type var/www/bwap/documents. And yes. And here's the result of that command. Now, of course, for different operating system commands, you'll need to do all these things again. So actually, SQLmap has another parameter for this. So use this query and change it here to OS shell. So choose for and no. Choose to provide the writable folder, and type var/www/bwap/documents. Okay, so we get the operating system shell. Now you can type the operating system commands. And it looks like it's a Linux server, so I'm going to be typing these ones. Okay, so this is the basic usage of SQLmap. I know it's been a kind of a long lesson, but in the next lessons, we are going to dive more into, let's call them advanced scenarios. SQLmap does a great job with every SQL injection. So using its options, you can exploit many hard SQL injection vulnerabilities. So in this lesson, we're going to exploit such an injection. Now from the menu, open SQL Injection Login Form User. And this is a login form. And the developer wants us to bypass this form. So it's the same with the login form hero. But the code is different. So when you write a wrong login, it says invalid credentials. And if you type a single quote, you get a SQL error. And that's good because that means that we can break the syntax. So now we need to find the best syntax to exploit. But it's not that easy. The answer's in the code. So let's open terminal and view SQLi_16.php. These are the regular checks. So scroll down to the actual part, and here it is. The developer makes a different thing here. So on the hero form, the developer checks the login and the password in the same query. But on this form, it's not the same. The developer hashes the password provided, then checks login only. Now, if there is a suitable login, then they compare the hashes. And if the hashes match, the user is authenticated and the message is printed. Otherwise, an error message is sent to the page. So we can even accomplish an injection over login, but we cannot see the output on the page. You know why, right? Because the extra check happens outside the query of the password hashes. Okay, so go back to Firefox. Refresh the page for a clean view. Then enable Foxy Proxy. Now type something in the login field and go to Burp. So the request is here. Okay, copy the request to a file and save it. You can then let it go. We are done with Burp, so open terminal again and then type SQLmap-R to point to the saved request file, -plogin to test the login parameter in request. Of course, you can add the H parameter for special HTTP headers. SQLmap will read the file and fudge the login parameter in the request. Now it will send exactly the same request in the file by adding the special headers. Okay, then hit enter. It detects an injection for MySQL. And now because we don't provide the DBMS parameter, it asks this question. Do you know the answer? There's no need to test for other DBMSs. A new question, of course, test for other types. So it finds different types of SQL injections. So accept this as well. No, don't test for others. Okay, it's finalized. SQLmap detects 3 types of SQL injection. So we can go with one of them. So just use the same query and add technique as a parameter. Type E for error-based SQL injection. And there's the result. So now we can use some other parameters, fingerprint and banner information. Boy, it executes quickly. So the point here is SQLmap uses error-based techniques to get this data. But if we do it manually, believe you me, it will be mind-blowing, mind-numbing perhaps. Anyway, the rest of the options you're going to want to use will be done with this technique. So get the current database and the user, and the result is here. So I hope you can see as well that SQLmap provides us a super usage experience. Sometimes, for some reason, web applications try to perform tasks by executing system-level commands. So in order to run commands, web applications communicate with the OS. So if an application doesn't do this properly, this functionality can be exploited. So the OS command injection vulnerabilities occur at this crossroads. So due to insufficient input validation, a user can inject OS commands via a web interface like an SQL injection. And these commands will be executed by the web server OS. Now, depending on the level of privilege that the web server software has, the result can be devastating. Don't let's fool ourselves. So open up Kali and log into BWAP. Choose OS command injection. And it's a sample page doing OS level things. And it shows the DNS information for the input value. Now, I would avoid querying the NSA, but you can go ahead and do it. No, strike that from the record. Okay, so type google.com and look it up. So something does happen. What is it? So let's view the source. So maybe we've got something here. Well, nothing's here either. So go back. Open your terminal. Now I'm going to view the code. So scrolling down. Okay, so based on levels, it looks like there are some security checks. We can look for check 1 and check 2 later. So keep scrolling down. So here's the main part. As you can see, the page use shell exec is a built-in function to execute NSLOOKUP command on the operating system. So that's all here. The functions are in this file. So here are the command injection check functions. So the first one clears the ampersand and the semicolon. And the second function calls for built-in PHP function escape command shell. So this function is used to escape system commands. Okay, enough with the code. Now, after the NSLOOKUP command comes the target. So in a low level, there's no check. We can run several OS commands after the target by adding some special characters. Now let's delete the NSA address. Type google.com and pwd, and then go. And we see the BWAP directory. I'm so bored by deleting the NSA each time, but I'm just a little paranoid. So let's enable Foxy Proxy. We can choose from autocomplete, then go to Burp. Nothing to change here. So send it to the repeater and then let it go. Open the repeater now. Yeah, I think you like this tool. I know I do. It's really handy though, right? Never mind. So send the first request as it is. And yeah, so we can get the response. And then now we can modify it here. You can do it however you want. I have a list. And I'm going to share it with you. So you can try, many possibilities. What do I hear you say? Where's the password file? Nah, I didn't forget it. It's here. With what I do, it's actually routine. So I find the vulnerability, then display some important files. Then I try to open a basic reverse shell with netcat. And I typically do not break my routine. So I'll type which NC, and scrolling down, yeah, it's here. So now I'm going to paste the one-line netcat shell. And before sending, let me make netcat listen. So now netcat listens for incoming connections. And go to the repeater again. Click on the send button. Well, I think we got the shell because there's nothing here on the right pane. So let's open up the terminal and see the shell from bbox. So you can type some bash commands, ID, uname, who am I, just like that. Now, I hope you remember what we did in the blind SQL injection lessons. We saw how to perform a Boolean and time-based blind SQL injection exploit. And of course, manually exploiting such a vulnerability is a time-consuming event. And it's also just very hard to go step by step. So we can use SQLmap to get over these obstacles. So first, I'm going to start with a Boolean-based one. And so there's a search box here. I think you know what's happening. Just enable Foxy Proxy, then type something in and search. Now go to Burp, and the request is here. So before forwarding, copy it to a file. And I'm going to use the same file and save. Then let the request go. Okay, open your terminal, then type SQLmap-R and request the file path. ptitle hpentest:28.08.2019 and run. That's funny because we're looking for a Boolean-based SQL injection, but we discover a time-based one. Yeah, so you can skip testing the others. Okay, so yeah, the exploit is with an integer value. Okay, again, and this can always happen to you. Okay, now, directly I'm going to point to the Boolean-based injection. B is for Boolean-based. It executes, but nothing is found. So maybe providing the DBMS can help. but nothing is found. Oh no, I'm getting nervous. Okay, so I'm going to add 2 more parameters. Level 5, there are 5 levels. The default value is 1, where a limited number of tests or requests are performed. And vice versa, level 5 will test verbosely for a much larger number of payloads and boundaries. So all in all, the harder it is to detect an SQL injection, the higher the level must be set. And risk 3, and there are 3 risk values. The default value is 1, which is innocuous for the majority of SQL injection points. Risk value 2 adds to the default level the tests for heavy query time-based SQL injections. And then value 3 adds also OR-based SQL injection tests. Super! All right, so finally we discover the Boolean-based blind injection. No, don't test any other. Just look at the result. The SQLmap discovers a hard injection type for us. Okay, so bring in the banner data for me. And sure enough, it brings the banner information for the operating system, web application, and server. So now think how hard it was for us to get 1 character of the version information. Okay, so get the current database. Okay, something went wrong. Because the SQLmap runs in single thread mode, some data retrieval problems can happen. But I'm going to show you that thread a few seconds later. So before adding threads, I will add these parameters. Prefix will add what I write before SQLmap's payload, and suffix will add what I write after the SQLmap's payload. Then I can refresh the SQLmap session to start exploiting from the beginning. Now have a look at the payload. It puts everything in place. So now get the current user. Okay, and add threads 10 to retrieve data fast. Now, I couldn't see what happened, did you? It was very fast. So we can use the threads parameter for bigger result sets. Yeah, let's see, for example, this one. And make the threads 10. Look at how fast it is. So no and no, I don't want to crack hashes now. Okay, so I think we're done with the Boolean-based SQL injection. So let's have a look to see if there's another one. Okay, so go to Firefox, open an appropriate page from the menu, and I need a request file. So type something in and search, open Burp, and the request is here. So copy this to a file and save. Okay, so go to terminal again and then run. And it will get a time-based blind SQL injection. Okay, so we know this is not a surprise. We can also point with a technique parameter like that. Okay, so get the banner information. Oh yes, please do optimize. Okay, so I'm going to stop it here because even SQLmap has its boundaries. So as we've done, SQLmap should also wait in time-based SQL injections. So now you may think, well, adding threads to the parameter can solve it. Well, good thought, but I am so very sorry. It doesn't work for time-based SQL injections. And as you can see, SQLmap is very clever. It completes the previous data retrieval process. Okay, so I just can't wait that much. So finally, we come to the end of the SQL injection part of this course. I hope you enjoy that. Now, I hope you remember what we did in the blind SQL injection lessons. We saw how to perform a Boolean and time-based blind SQL injection exploit. And of course, manually exploiting such a vulnerability is a time-consuming event. And it's also just very hard to go step by step. So we can use SQLmap to get over these obstacles. So first, I'm going to start with a Boolean-based one. And so there's a search box here. I think you know what's happening. Just enable Foxy Proxy, then type something in and search. Now go to Burp, and the request is here. So before forwarding, copy it to a file. And I'm going to use the same file and save. Then let the request go. Okay, open your terminal, then type SQLmap-R and request the file path. ptitle hpentest:28.08.2019 and run. That's funny, because we're looking for a Boolean-based SQL injection, but we discover a time-based one. Yeah, so you can skip testing the others. Okay, so yeah, the exploit is with an integer value. Okay, again, and this can always happen to you. Okay, now, directly I'm going to point to the Boolean-based injection. B is for Boolean-based. It executes, but nothing is found. So maybe providing the DBMS can help. But nothing is found. Oh no, I'm getting nervous. Okay, so I'm going to add 2 more parameters. Level 5. There are 5 levels. The default value is 1, where a limited number of tests or requests are performed. And vice versa, level 5 will test verbosely for a much larger number of payloads and boundaries. So all in all, the harder it is to detect an SQL injection, the higher the level must be set. And risk 3. And there are 3 risk values. The default value is 1, which is innocuous for the majority of SQL injection points. Risk value 2 adds to the default level the tests for heavy query time-based SQL injections. And then value 3 adds also OR-based SQL injection tests. Super! All right, so finally we discover the Boolean-based blind injection. No, don't test any other. Just look at the result. The SQLmap discovers a hard injection type for us. Okay, so bring in the banner data for me. And sure enough, it brings the banner information for the operating system, web application, and server. So now think how hard it was for us to get 1 character of the version information. Okay, so get the current database. Okay, something went wrong. Because the SQLmap runs in single thread mode, some data retrieval problems can happen. But I'm going to show you that thread a few seconds later. So before adding threads, I will add these parameters. Prefix will add what I write before SQLmap's payload, and suffix will add what I write after the SQLmap's payload. Then I can refresh the SQLmap session to start exploiting from the beginning. Now have a look at the payload. It puts everything in place. So now get the current user. Okay, and add threads 10 to retrieve data fast. Now, I couldn't see what happened, did you? It was very fast. So we can use the threads parameter for bigger result sets. Yeah, let's see, for example, this one. And make the threads 10. Look at how fast it is. So no and no, I don't want to crack hashes now. Okay, so I think we're done with the Boolean-based SQL injection. So let's have a look to see if there's another one. Okay, so go to Firefox, open an appropriate page from the menu, and I need a request file. So type something in and search, open Burp, and the request is here. So copy this to a file and save. Okay, so go to terminal again and then run. And it will get a time-based blind SQL injection. Okay, so we know this is not a surprise. We can also point with a technique parameter like that. Okay, so get the banner information. Oh yes, please do optimize. Okay, so I'm going to stop it here because even SQLmap has its boundaries. So as we've done, SQLmap should also wait in time-based SQL injections. So now you may think, well, adding threads to the parameter can solve it. Well, good thought, but I am so very sorry. It doesn't work for time-based SQL injections. And as you can see, SQLmap is very clever. It completes the previous data retrieval process. Okay, so I just can't wait that much. So finally, we come to the end of the SQL injection part of this course. I hope you enjoy that. Sometimes, for some reason, web applications try to perform tasks by executing system-level commands. So in order to run commands, web applications communicate with the OS. So if an application doesn't do this properly, this functionality can be exploited. So the OS command injection vulnerabilities occur at this crossroads. So due to insufficient input validation, a user can inject OS commands via a web interface like an SQL injection. And these commands will be executed by the web server OS. Now, depending on the level of privilege that the web server software has, the result can be devastating. Don't let's fool ourselves. So open up Kali and log into BWAP. Choose OS command injection. And it's a sample page doing OS level things. and it shows the DNS information for the input value. Now, I would avoid querying the NSA, but you can go ahead and do it. No, strike that from the record. Okay, so type google.com and look it up. So something does happen. What is it? So let's view the source. So maybe we've got something here. Well, nothing's here either. So go back. Open your terminal. Now I'm going to view the code. So scrolling down. Okay, so based on levels, it looks like there are some security checks. We can look for check 1 and check 2 later. So keep scrolling down. So here's the main part. As you can see, the page use shell exec is a built-in function to execute NSLOOKUP command on the operating system. So that's all here. The functions are in this file. So here are the command injection check functions. So the first one clears the ampersand and the semicolon. And the second function calls for built-in PHP function escape command shell. So this function is used to escape system commands. Okay, enough with the code. Now, after the NSLOOKUP command comes the target. So in a low level, there's no check. We can run several OS commands after the target by adding some special characters. Now let's delete the NSA address. Type google.com and pwd, and then go. And we see the BWAP directory. I'm so bored by deleting the NSA each time, but I'm just a little paranoid. So let's enable Foxy Proxy. We can choose from autocomplete, then go to Burp. Nothing to change here. So send it to the repeater and then let it go. Open the repeater now. Yeah, I think you like this tool. I know I do. It's really handy though, right? Never mind. So send the first request as it is. And yeah, so we can get the response. And then now we can modify it here. You can do it however you want. I have a list. And I'm going to share it with you. So you can try, many possibilities. What do I hear you say? Where's the password file? Nah, I didn't forget it. It's here. With what I do, it's actually routine. So I find the vulnerability, then display some important files. Then I try to open a basic reverse shell with netcat. And I typically do not break my routine. So I'll type which NC, and scrolling down, yeah, it's here. So now I'm going to paste the one-line netcat shell. And before sending, let me make netcat listen. So now netcat listens for incoming connections. And go to the repeater again. Click on the send button. Well, I think we got the shell because there's nothing here on the right pane. So let's open up the terminal and see the shell from bbox. So you can type some bash commands, ID, uname, who am I, just like that. So in the previous lesson, we performed a basic OS command injection example. Now, from the very first point to a reverse shell, we've done everything manually. And now, if you're new to this field, or even if you're an experienced veteran, sooner or later, you're going to want to automate what you do. So you can use tools or code your own. So in this lesson, I want to use the tool Commix for the command injection. Commix actually ships with Kali, and this is the latest version. However, I couldn't run it due to a bug, and I didn't even get to fix the bug. So instead of using this version, I'm going to use a previous version. So it's a long way around of just showing you that I will go to its GitHub page. And you see under the releases, you're going to see different releases. So I'm just going to download this one. I'll download the source code and save it. Then go to the download folder, extract the files. Okay, so now I'm going to go back to the terminal and go to that directory. All right, so here are the files. And you can run it directly from here. Show options by specifying the H parameter. It has many options. You can test every one if you like, but I'm going to go on. So go to Firefox and send the traffic to Burp. We're going to click Look Up. Now, copy this request to a file and name it whatever you want to and save. Then let the request go. Now, we have nothing with Burp and Firefox. So, let's use Commix. So type commix.py-r to specify the file that we saved. P is for the parameter in the request to test, and all to test and check for everything Commix tests. And hit enter. So it gets something. Okay, I'm not alone. Commix also displays a password file first. Now it also enumerates this system in detail. And below, it asks to open a shell style interface. So of course I hit enter to accept. And this is the Commix style shell. So now you can run OS commands from here. uname -a, ID, and Commix can also create a reverse shell for us. So type in reverse TCP. Now, you may recall Metasploit. Okay, so set the local host to the IP address of your Kali, and then set the local port on Kali to listen for the reverse connection. I'm going to say 4445, and now you must choose which type of shell you want. And let's see, we've already done the netcat style shell, so choose 2. Now you must choose which type of reverse TCP shell. So I'm going to say 8. And it will generate the payload for us. And then create the Metasploit resource file. All right, so I'm going to just split the window, then copy the resource file, and paste it in here and add a queue for the parameter to start Metasploit in quiet mode. Then hit enter. Now, the RC file creates a multi-handler with its options, and then exploit. So that way the generated reverse TCP payload on bbox connects to the handler on Kali. And the interpreter session is open. So type sysinfo. And this command shows a short view of the system and the session information, and the get UID for the user of the session. Now you can run your post modules or do some privilege escalations on the system. That's entirely up to you, whatever you want. Oh, and one last thing. So as I observe this shell, it's not as consistent as the Metasploit reverse TCP shells. So I don't know why this would be, but in your system, it may indeed still be different. Contact forms. Need I say more? Before Twitter and other social media applications and their widespread use, there were contact forms. And now people choose to tweet directly to the company or organization or whatever it is. So yeah, I'm being a little glib. I realize that there are contact forms still in use, widespread actually, in different web applications. And it's possible to use the emailing system behind such a form. All right, so in this lesson, we're going to try such a scenario. So I want you to open Kali, and as always, log into BWAP. Open the mail header injection. Now, due to an overused protocol, the name can change. So for this one, you can use the SMTP mail header injection as well. Anyway, it is a simple contact form. At least you can think it is. All right, so let's view the source to control for anything suspicious. Well, there's nothing to see here. So first, I want to show you the configuration here. Okay, so view settings.php. So here's my SMTP configuration. I'll just change it to these values because a few times I've gotten some errors, but this works fine. Okay, so now let's view the mail injection page. And it validates the email address that you enter for medium level as well as high. And then set the mail server. So then if the level is set to high, it uses another function called mailcheck2. Then it creates the mail body and sends it off. So mailcheck2 is in this file, and I'm going to find it. Well, that didn't take long. Here it is. So it decodes the date and then uses a built-in function to validate the email. Okay, so go back to Firefox, enable Foxy Proxy, fill in the form, and I'm going to use this email address, and then send. So Burp will capture the request for us, and here's the data. And then at the back end, the server will use this email address as the sender's email. And it will send the email to BWAP recipient at mailinator.com. And we can send the request to the repeater for using later, and then let it go. So now go to the BWAP recipient's inbox in mailinator.com. And here's the email. And this is all the email information. Subject and from headers are very important to us. Actually, we can modify only from the header for metadata, but that's okay. So go back to Burp and let's open the repeater tab. I'm going to inject some mail headers into this request. So type $0A CC : other inbox at yopmail.com. Add the %0A, and that's the carriage return character, by the way, and then send it. And we get the response. So as you can see, the mail is sent. So now let's go to Chrome and open yopmail.com. And in another inbox, here's the email. So look at the headers. So this inbox is present in the CC header. Okay, so go back to Burp. So these kinds of vulnerable forms can be used to spread phishing mails and just all kinds of dreadful stuff. So now we can do a quick example. You can create the phishing email body by yourself. But for me, I'm going to use some templates that I happen to have found on GitHub. So open Firefox and go to this address. Now, if you scroll down, you're going to see the templates. There are different email templates here. And okay, so I'm going to choose Basic Full Plan. Looks like this. Now, I think it's a simple and convincing template, yeah? So download it. And it's in the Downloads folder, so extract the files. Now go to the template code under this directory and open the HTML document with a text editor. Copy the source and go back to Burp. Open the Decoder tab, paste it here, and from the menu on the right, choose URL Encode. Then copy the encoded output. Go back to the Repeater tab, delete this part, and add another return character. Then add the message header. Paste the output here, then send. So the response came back. So that means there's no problem. So now go to the recipient's address and click to have a look. Now, I didn't add CSS code, and I didn't want to make something else, but you can always make it pretty and convincing if you want to use it. Also, you can copy the email format that your customer uses and use that. I know people who can even click the link in this email, so people still do. So with a little bit of effort, you will spread a really good phishing email, and you'll have lots of friends. So until now, we've injected JavaScript, SQL, and XPath code into legitimate data. Now, it may also be possible to inject different languages. So another popular injection type is PHP Code Injection. So PHP code can be injected into a program or script from some outside source. So the added code is part of the application itself with the same permissions as the application. Now, imagine the consequences with that. So in BWAP, there's also an example for this attack. So you want to have a look and see how it works? Open your browser and log into BWAP. And from the menu above, choose PHP Code Injection. And just like it says, this is just a test page that reflects your message. So if you click here, it writes the phrase test below, and the data transmits over the URL. So view the page source, and here's a part containing the link. The message parameter in the URL has a default value, test. All right, so now I'm going to check here. I'm going to check into something and see how the link doesn't change, but the value below is changed to something. Okay, so I think that what we type here in the message parameter is reflected back to us. Okay, so now I'm going to add here a semicolon, and then I'll observe how the application behaves. So it doesn't print the semicolon. So let's see, maybe it escaped or it's interpreted in the back end. So you can also add a piece of PHP code after, echo something, and hit enter. Well, isn't that super? It executes. Okay, so delete the echo function and write PHP info. Well, that executes as well. So that's perfect. We can execute PHP code now on the back end. So PHP has several functions to execute operating system commands. System command is only one of them. So we discover the OS is Linux. So print working directory. And it shows BWAP's directory. So somehow we are able to run commands on an operating system. But we don't display the content of the magic file because it's not a real hack, right? And I mean, that's good because this is the content of the password file. So now it's a hack. Okay, so let's move on with Burp and enable Foxy Proxy and then refresh the page. Open Burp, and I just intercepted it to use repeater. So send it to the repeater and let it go. And here's a request. So send it. It executes again. So now I'm going to delete from here the file name. And let's have a look, see where the netcat binary is, which NC. Now, due to URL encoding, I'll use the URL encoded values of spaces and quotes. So I'll send it. Netcat is here under the bin directory. So now I'm going to use netcat to open a reverse shell on bbox. I open the decoder tab, and I'm going to paste the reverse netcat shell here. Now this line of commands will help us to communicate over another channel with bbox. And encode as URL. Copy this long output and paste it instead of this payload. And then before sending the request, open the terminal and make sure that netcat is listening. And it can't listen without a port. So let's add 4443, then go back to repeater and send. So, as you can see, there's nothing on the right side because of the execution of reverse shell commands. So, go to terminal, and here's a session. bbox connects back to Kali, and you can type Linux commands now. uname -a, it is bbox. So this type of shell is a little bit weird. So now if you write this line of Python, you will get a shell-like bash shell. And yeah, I think it's good. So you can type some commands. Yeah, it is cool. So, okay, overall, that's how we use a PHP code injection. And also create a reverse shell. Automated tools are an important part of pen testing of a web application. To be able to understand if there's a vulnerability on an input field, you should send thousands of different payloads. For example, you have to try hundreds of payloads to be sure that there is not an SQL injection vulnerability in the field. There may be tens or hundreds of input fields in a website. So, only for the SQL injection vulnerability, you have to give hundreds of thousands of tries in a typical web application pen test. So if you want to test the application manually, be my guest. It's going to take months. So to make it faster, you should try using automated tools. The OWASP Z-Attack proxy, otherwise known as ZAP, is one of the world's most popular free security tools. It can help you automatically find security vulnerabilities in web applications. So to answer your first question, what is OWASP ZAP? ZAP is a tool to find the vulnerabilities in web applications. It's completely free and open source. Because of the ease of use, it's ideal for people new to application security. ZAP is also a cross-platform tool, so you can use it on Windows, Linux, and Macs. It's easy to install. It requires Java to run. Everything else is included in the standard download packages. A full set of help files is included, and these can also be viewed on the web. And ZAP is a community project, so there are hundreds of volunteers to improve it and to add new components on it all the time. Zap provides the essentials that you'll need for testing web applications. First of all, it's a personal proxy to intercept and tamper with the HTTP and HTTPS traffic between the browser and the server. It provides both active and passive scanners. The passive scanner just examines the requests and responses, and it can detect certain types of vulnerabilities just on that basis. It runs all the time you use Zap, and it's safe to use on any site as it does not perform any attack itself. And on the other side, Active Scanner performs a range of attacks. So as you see in the next lecture, spidering or crawling can be used to crawl the application. For example, to find pages that you've either missed or which have been hidden from you. Zap can generate reports on the issues it has found, including advice and links to more information about the problems. It can also fuzz parameters, and you can use fuzzing to find more vulnerabilities that the automated scanners can't necessarily find. Capturing HTTP traffic. So as we've gone over, and hopefully you've learned, HTTP is the core protocol that carries everything between the web browser and the web server, right? So the browser sends requests to use the resources on the server, and also the server sends the associated response back to the browser. So while penetration testing, manipulating the HTTP messages is a basic and very important ability for you to have as a penetration tester. By intercepting HTTP messages, you can edit and change any part of the message and then, well, see what happens. So until now, we've just been looking at plain HTTP messages. Now we can capture and manipulate any part of the HTTP message on the fly using a local HTTP proxy tool. So a local HTTP proxy tool is one that sits in between the browser and the website, intercepting all the traffic that flows between them. So this is best done by acting as a man in the middle and then intercepting every request and response. It lets you intercept, inspect, and modify the raw traffic passing in both directions. Now, although there are several proxy tools, there's one called Burp Proxy, and that's pretty much the most widely used that I've seen. You can also use others, such as Z-Attack Proxy by OWASP, and there are several others included in Kali. But I like Burp Proxy a lot, and you will too. You will too. Burp Proxy comes in a suite named Burp Suite that includes tools like Spider, Intruder, Decoder, and a few others. It's developed and maintained by Portswigger Web Security. And the proxy tool that is the heart of Burp, that's the one that intercepts all the requests and responses. Burp can also automate customized attacks against web applications. And then the traffic between the server and the browser can be analyzed, modified, visualized, and eventually repeated multiple times. All right, so Burp Suite can be downloaded from portswigger.net. There are 3 download candidates here, and 2 of them are commercial products. You can compare them, and you can even buy them on this page. But for our purposes and the purpose of this course, the Community Edition is just dandy. So that's the one we're going to use. So let's click on the download button to see our download options. And the download flavors are listed here according to major operating systems and version numbers. Now, if you're using a different system, click Other Platforms, and then you'll find the suitable flavor here. But now we're going to use Kali as the attacking machine during our course, right? So that means that Kali has pre-installed a version of the Community Edition. Just remember to update your system before using the tools in Kali. So, what does that mean? Let's open up Burp. Let's click on this icon. And a splash screen will welcome you. Click OK, and then a project screen will come up. Now here you can create or open an existing Burp project, but I think here this note in red tells the situation quite clearly. Next. Burp gives you a way to save the configuration while working, and if you want to, you can load your saved configuration from this window. Now, I don't have a configuration file here, so I don't need to do anything. So let's click Start Burp. Wait a few seconds. And the main window opens. So when I recorded this video, this is the latest version. And on the right side, there are advertisements for the Pro version. And on the left side, there are tasks and Burp logs. So I'm just going to hide the ad. And let's look at the tools in Burp Suite. Target. So this tool allows you to visualize your target application's contents in a folder structure. It shows all the content that has been discovered by manually browsing the web application. Then it extracts a map of the application, and this helps to define the target scope for the application. Proxy. So the Proxy tool lies at the heart of Burp's user-driven workflow. It operates as a web proxy server and sits as a man in the middle between your browser and destination web servers. So this allows you to intercept, inspect, and modify all raw web traffic passing in both directions. Intruder. So this is a powerful tool for carrying out automated, customized attacks against web applications. It's extremely powerful and configurable, and it can be used to perform a huge range of tasks, from simple brute force to the guessing of web directories. So this process can help to identify web application security flaws. Repeater. So it's a simple tool for manually modifying and then reissuing individual HTTP and WebSocket messages, as well as analyzing the application's responses. So you can use a repeater for all kinds of purposes, such as changing parameter values to test for input-based vulnerabilities, and other things. We'll get there. Sequencer. This analyzes the quality of randomness in an application's session tokens or some other important data items that are intended to be unpredictable. And here's the decoder. It's a simple tool that allows you to encode and decode data. It's capable of intelligently recognizing several encoding formats using heuristic techniques. Comparer is a handy tool to compare, obviously, but you compare visually any two items of data, such as pairs of similar web responses. Logger is a network activity recording tool. Burp Suite's Logger captures any HTTP traffic for inquiry and analysis, but it's especially handy for investigating what happened if Burp Suite is producing unexpected results. Looking at the details of what Burp Suite is sending when your work involves session handling. Making sure that long-term ongoing tasks are still running. An analysis of any issues that need visibility into what Burp Suite is actually doing. Extender. So Burp allows us to add our own modules to increase Burp's functionality. And the Extender tool also allows us to load Burp extensions from the Burp App Store. You can view the extensions from here and list them. Now, Project Options is a place that you can define some global properties about Burp and your current Burp session. And then User Options, well, that's a place that you can add Burp NTLM authentication credentials and proxy information while testing. You can also add your client SSL certificates under the SSL tab if you need them in a test. And it's also possible to change user interface options. And of course, you can also customize the user interface right here from the Display tab.
Let's see the best way to intercept HTTPS traffics using Burp. The safest way to intercept HTTPS traffics is to install the PortSwigger certificate on your browser. PortSwigger is the owner of the Burp Suite tool. First, let's delete if we have any previously installed PortSwigger certificates. If you didn't try to install a PortSwigger certificate before, you can ignore this step. Open Firefox. Now, from the menu button at the upper right side of Firefox, follow the path to open the certificates list. Preferences, Advanced from left, Certificates, and click View Certificates button. Look at the first if there is any PortSwigger certificate and delete it if there is. Now it's time to run Burp Suite. Configure the browser to use Burp. For this purpose, from the Foxy Proxy icon, I choose location host 8080, which is designed to listen to port 8080 of the local machine. Type http://burp/ in the address bar of Firefox. Click CA Certificate, link at the upper right-hand corner, and save the file. It's now saved in the download folder on my computer. Now let's import the download certificate. Again, from the Firefox menu, follow the path to reach the certificate page. Preferences, Advanced, Certificates, and click the Import button. Choose the certificate you downloaded a few seconds ago. Check Trust this CA to identify websites, at least, and click OK. Now it's time to intercept an HTTPS traffic. I'll intercept the traffic of google.co.uk page. Go to the Burp Suite. As you see, the intercept is on and the request is caught by the Burp Suite. To test if everything is okay, I'm going to search for a word, intercept the traffic, and change the word with another one. I write OWASP in search bar and hit enter. Burp caught the request. I replace the word OWASP with CI security and turn the intercept off to allow the traffic flow. When I go back to Firefox, I see that the word CI security has been searched instead of OWASP. It works like a charm.